Here's another example where we can use the chain rule. See here we have y equals to the 10th root of 17 plus 20x to the 8th power. We will use the chain rule. First of all, we need to switch this radical into an exponent. To do that, we're going to write y equals to 17 plus 20x to the 8th power. Everything is raised to 1 over 10. This is how you switch from a radical into an exponent form. The next step is to find dy over dx using the chain rule. So the first thing is to bring the power down, 1 over 10 times 17 plus 20x to the 8th power. Everything is raised to 1/10 minus 1 times the derivative of what's inside, which is the derivative of 17 is 0, plus the derivative of 20x to the 8th power is 8 times 20, 160x to the 7th power. Now we're going to simplify, so this is 1 over 10 times 17 plus 20x to the 8th power. Everything is raised to negative 9 over 10 times 160x to the 7th power. I can multiply 160 times 1/10, which is going to give me 16. So I will have 16x to the 7th power times 17 plus 20x to the 8th power, all to the negative 9 over 10. This is not very clear. This is 9. Now I'm going to turn this exponent into a positive exponent and then turn it back into a radical. I have 10 in the denominator. That means I know I'm going to have the 10th radical. First of all, I will need to make the exponent positive. So we will have 16x to the 7th power over 17 plus 20x to the 8th power, everything to the 9 over 10. Here the 9 is going to stay as an exponent for the parentheses, and 1 over 10 is going to be a radical. So this will turn into 16x to the 7th divided by the 10th root of 17 plus 20x to the 8th power, everything to the 9th power, and that is the final answer.